All these neurons are going to go ahead into the optic nerve, and all these cells that are rods and cones with pigment in them are going to transform this light energy into electrical impulse. That is all that the eye is doing. And not only that, but the system of lenses is not fixed. What do I mean by it's not fixed? It's not mobile either. But what it does, it changes the curvature of the lenses in a way that you can actually focus on somebody that's 4 feet away, on somebody that's 3, on something that is 2 inches away. And it does this with the same eye, but the curvature of the lens changes because of the muscles that are pulling on the lens and makes the lens bulkier or thicker. That is not what the camera is doing, because the camera has usually fixed lenses, right? Even more than this one for the newer models. But it does that by increasing the distance between the lenses, mechanically increasing the distance. Leaving that aside, the eye itself has structures that are on the outside of the eye, like the extrinsic muscles. And you see here muscles that are actually connected to the eye itself and are moving the eye. We have 6 extrinsic muscles that are surrounding the eye. Those muscles are, I'm going to go right here. Everybody can see this model because this is really good. So we're talking about 4 muscles that are straight, and they're called rectus, because rectus comes from erect, which means straight. So we have superior rectus, inferior rectus, which is under knee. We have lateral rectus, we have medial rectus, we have superior oblique, which is this muscle here, and we have inferior oblique, which is, we see this better on this model. So on this model, we know which one is lateral because it's towards the temporal bone. Medial is towards the nasal bone. But here we don't have these bones. Well, what do we have in this model? In this model, we have this gland. This is what we call the lacrimal gland. Lacrimal gland is producing ears. Exactly. So lacrimal gland is always lateral. Always lateral. So if the question is going to be name this muscle, what would you say? Rectus, very, very, very good. And the opposite muscle is going to be medial. The muscle here on top would be this muscle here would be rectus. Why I can't put a sticker there? So how about this guy?
That's the oblique.
Which one?
Lateral.
Inferior oblique. Inferior oblique is going down. And this is actually is the superior oblique, right? Because this is actually the tendon of the superior oblique. As you see it here, it starts with the tendon and then it continues with the muscle. So we know all the extrinsic muscles of the superior rectus, inferior rectus, lateral, medial rectus, inferior oblique, superior oblique. If we take these muscles out and the lacrimal gland out of the equation, we end up with a more or less sphere that is absolutely white on the outside. It has layers. The eye itself has outermost layer is absolute white. It doesn't have any blood vessels, right? And the reason it doesn't have any more any blood vessels is for a simple reason. It doesn't have blood vessels. So you're going to say, but just 1 second, when my eyes are red, that's because of blood vessels, right? But these blood vessels, they are embedded into a very thin, very transparent layer that's called conjunctiva. That's why inflammation of this layer is called conjunctivitis. So that's your pink eye, right? And that's why they tell you don't scratch. But yeah, so the outermost layer, the one that's absolutely white, is sclera. And if we open the eye, excuse me, the innermost layer, the layer that is here, it's called the retina, right? We have a correspondence here at the retina on this side also, retina. In between retina and the sclera, we have the choroid. The choroid is this, the choroid is this brownish, yellowish, reddish layer, calling it black, the new black. Yes, this is the choroid, right? Sclera, choroid, retina on the inside. In terms of lenses, because we're, talking about lenses, the first lens of the eye is this portion of the eye that continues the conjunctiva, but is not, and the sclera, but is not opaque, it's transparent. See, this portion here is transparent. And it's called, how do you call this portion? No, retina is inside. Retina is
That's the
inside.
man.
Right. It is a lens. It is a lens. But this is where the all those surgeries in which they take LASIK surgery. So in a LASIK surgery, that's what they do. They take the cornea and they basically shave it, right? There are different procedures. I'm not an ophthalmologist. But his name, right? Sorry. But LASIK is when they fix the curvature of the cornea, and they're trying to improve your eyesight without glasses. Underneath the cornea, we have it's not it's a solution, it's a special, it's whatever. It's a liquid that is called the aqueous humor. Aqueous, because it's mostly water. Aqueous humor. Humors are liquids in the body, right? In general. And then the light travels through this open space here that is called the pupil. The pupil, right? The pupil, exactly. Take it out.
Professor, just a quick question. How would you ask a question about the liquid,
right?
Let's say the liquid.
Exactly.
Like, yeah.
So if we have, for example, this model, let's say we have this model, right? And a sticker is going to be put here, a sticker here with a number on the sticker, whatever corresponding to that question. And the question corresponding to the sticker would be, what substance is underneath this sticker?
Okay.
Like, aqueous. So this, you guys said, is the pupil. The pupil is the space. Is the space through which light travels, enters the eye, right? It enters the eye. Before it enters the eye, it travels through the lens itself. The other name for lens is crystalline, but I just go with lens. It's easier. So this would be the lens. The lens is connected through the suspensory ligaments to the papillary bodies. So these are muscles that are pulling on the ligaments, and they're stretching the lens, making it bulgier or less bulgy or flatter, depending on what exactly is that we want to focus on, right? You have a question? These guys? No, those are extrinsic muscle. Extrinsic means outside of the eye. These are part of intrinsic muscles because they're Make sense?
Mhm.
Awesome. So again, suspensory ligaments, papillary muscles. All these papillary muscles are coming somehow. They're spreading inside the eye, and they form what we call ora serrata. O-R-A, and then the next word is S-E-R-R-A-T-E. A-T. Ora serrata. Serrata comes from serrated, just like a serrated knife that you cut bread with. So it has these little teeth, or whatever they, well, it has better like, right? Yes. Yes. What? So ora serrata. Inside the eye, we have a viscous substance, more like jello-like, that's called the vitreous humor. Vitreous humor. Aqueous humor, vitreous. Vitreous comes from glass. Vitreous is glass, so glassy humor, right? And then in the very uh, posterior aspect of the retina, we have this yellow spot here that is called macula lutea. Not macula natata. No, that is from another movie. All right? Hakuna Matata. Now I remember.
Can we take one that was yellow spot?
No. I'm sorry. Sorry, I tried, but no, doesn't work. So macula lutea. Macula stands for a spot. Macula stands for spot. And lutea stands for yellow. It's all Latin. In the very center of macula lutea, we have fovea centralis. Fovea means little tip. Centralis in the center of the yellow spot. Lateral, well, actually it's medial to the macula lutea. We have this area here that does not have any retinal cells. There are no pigment cells. There's nothing here that transforms light into electrical impulse. It's called a blind spot or the optic disc. So this would be the optic disc. Again, a question. How could it be question? How could it be yes? The sticker is going to be here, an arrow pointing here. And the question would be name this structure. Sure, absolutely. So the sticker could be here. The arrow from the sticker point. And the question name this structure. This structure is called the optic disc. Yes. Yes. On Connect, but I'm going to tell you where on Connect. It's on Anatomy and Physiology. It's on Anatomy and Physiology Review. As you open your Connect and you're seeing your book, and you're down on the right-hand side is a review. Click on that. I'm going to show you how to get to all of these. Right? Plus movies, plus questions, plus tests that you can self, So this is everything that I have for you guys in terms of the eye. I have nothing else other than the fact that the colored part of that is under the cornea is called the, how do we call this colored part? And the iris has all kinds of colors. Do we have a blue iris? Right? What? What? Right? So the iris has different colors, right? That depends on our gene, very much, right? So iris, pupil, right? Lens, ora serrata, retina, macula lutea, fovea centralis, optic disc, extrinsic muscle, right? Did you guys get everything that I said? That's what. Yes. Sclera or superior, just inferior oblique.
Pablo, you know, sis,
Sure. The what the yellow thing? Macula. Yeah. That's it.
And there was another
Fovea, centralis.
so like two questions could be
Yes,
yeah.
yes. So, okay, let's do this. So, macula lutea is not this, okay? But if we are taking it so it's bigger, so we can see, imagine that this dark spot is actually yellow, and it's the macula lutea. And in the very center of it, there is a dip. And that dip is the fovea centralis. Why is it so? The guy is like telling us this. Well, macula lutea has a majority of that is vision in daylight, in detail, like HD. Now, fovea centralis has the highest resolution. So if I'm looking at you, what I see is in my macula lutea, I see your face, I see your hands, I see your shirt. What that I see with the macula lutea, your nose, your lips, and your eyes is where I'm focusing on, and I see them with fovea centralis.
yeah, when I like con colons and I don't know,
In rods.
right.
Yes, they are. Exactly.
Colon
Exactly.
guts.
Now, the highest concentration of cones are in macula lutea, especially in fovea centralis, because this is what we use to see like really, high definition and focus and really fine
And
details.
to differentiate colors.
And for colors, the rods are the cells, the other type of pigment cells in the retina. They're also in retina, but they're towards the edges of they're towards the peripheral vision. They are for vision in light conditions and in the poor light conditions, like evening, dusk, nighttime, right? Basements, and not color. They're just shades of gray.
So Professor, if there's one error that's like pointing at the macula, like how would we know which one to tell you?
It's going to be a sticker, and it's going to be an arrow, and it's going to ask you name the structure, because they're so close to each other. I'm not going to make the difference. So whatever you tell me, it's correct. Either you say macula lutea or fovea centralis, I'll take it as correct. I'll give you a fruit.
Got it.
Sorry.
For us, you as many times as you. Now, good question. Everybody is comfortable? I give you guys 15 minutes.